All right, so looking at our examples here, notice I changed the BK to 10 to match, and then we're going to bring those same ones down as we get down here. We're going to use the mean and standard deviation that we use here, so it kind of follows as one problem. All right, so looking at our parameter, right, and so we're looking at mu1 minus mu2. And what we want to try to find is the mean difference in fries. So the true mean difference in the number of fries in a McDonald's and Burger King small fry. Okay, and then we're gonna estimate, and this time tells us at 95% confidence and then we get our data here. So our x1 hat is 38.2, and our s1 is 3.4, and it's 10. And then our Burger King, which is our x2, is 32.7. S2 is 4.1. And our n, since I changed it, is going to be 10, so that all fits together there. And then we're going to go to Staplet. And let's reset this. Turn this into fries. Hey, you would have raw data. We have standard deviation. So we got Mickey D's here, Burger King there. Our mean of this one it was 38.2 and 3.4. And 10 of those. And then Burger King is 32.7, 4.1. That's 10. Begin our analysis. We want 2 sample. We wanted 95 this time. So we perform that. And we get an upper and lower bound. So our interval .953 to 9.047. And then from there we can do our interpretation. So we are 95% confident this time. That, and this time they're both positive, that McDonald's small fry has between 1.953 and 9.047 more fries than a Burger King small fry. Okay. And then our margin of error, subtract those, we get what, 5.5, and then it's plus or minus 3.547. And then, like I said, continue down using that same data down here. We then look at, we're going to use our parameter, we're not going to rewrite that. So our null hypothesis, all right, is going to be that mu1 minus mu2 equals 0, that there is no difference in the number of fries in each. And our alternative is that McDonald's is going to have more fries in it. So mu1 minus mu2 is going to be greater than 0. And we take our same data set, so I'm going to use this data up here again, just so you can see how it all fits together. If you're doing start to finish. All right, and then once we do that, we're going to do our t-test. So go back over here, change the interval to t-test. We are greater than 0, which is what we want. So we perform our inference, and we get our t and p value. So t equals 3.265, and our p value equals 0.002 or 0.2% in our distribution. So there's 0 difference between them. We had a 5.5, which let me show that real quick. All right, so 38.2 minus 32.7 gives us that 5.5. So that's what we saw there. And we want greater than, so that's shaded area. So that shaded area, if we ran a bunch of simulated trials, would include 0.2% of the total data in that curve, meaning that the probability of getting 5.5 is 0.2%, and that is also the probability that our HO, our null hypothesis, is true, and that's a pretty low percentage. So since 0.2% is less than 5%, we reject HO and have very strong, add a little extra emphasis there since it's so low, convincing evidence that McDonald's small fry has more fries than Burger King's. And there you go. There is your sample. Again, with all this, you're just going to be doing one of these, whether it's one sample, two sample, whether it's categorical, so Z interval and Z test, or quantitative T interval and T test. So if you still have questions on this, I'll answer those. And specifically, once you have your project, your question, what type of data you're collecting, once you get that data, I'll help walk you through this as well. This is really just here to kind of help you think through what type of data you're collecting, what it should look like, and how you want to ask your question in that vein.